In this video, I'm going to show you how to use the arithmetic sequence formula to solve some more difficult questions. For example, I want you to find the first 4 terms of an arithmetic sequence where the 5th term is 24 and the 17th term is 60. Here, let's first again list our things that we know that we need to plug into the formula. So we have T1, N, D, and then Tn. So we don't know the first term, so I'm going to put a question mark there. N, we're taking a look at the first piece of information where T5 is 24, N is 5. And then the difference, again, we don't know that. Now, if N is 5, I'm now going to erase this Tn and actually put T5. So T5 we know is 24. Now we have 2 unknowns, and it's hard to, or it's actually impossible to figure out what T1 and D are if you only have this one set of information. However, we also know that T17 is equal to 60. So we're going to use this second piece of information to list out another set of T1, N, and D. And I'll put T17 this time because we know that's 60. So again, we don't know T1, we know N is 17, and we don't know what D is. Now, these 2 pieces of information do give us 2 unknowns that are the same unknowns. So I'm going to set them both up using our arithmetic sequence formula. So I'm going to say that T5 is equal to 24 equals to T1 plus 5 minus 1 times D. And simplifying, we get 24 equals T1 plus 4D. Okay, using T17 equals 60, we now have T17 equals 60, which equals T1 plus 17 minus 1 times D. And then 60 equals T1 plus 16D. All right, so we have 2 equations with 2 unknowns, but the unknowns are the same terms or the same variables. So what I can do is now solve by either elimination or substitution. Now everything's lined up very nicely, and T1 doesn't have a coefficient. So I'm going to solve by elimination. I like to put the equation with the larger numbers on the top. If both of them are larger, that's great. And then we'll put 24 equals T1 plus 4D underneath. And I'm going to eliminate by subtraction. So we're going to go 60 minus 24, which is 36, equals T1 minus T1 is 0, which is what we want. So we're left with 16D minus 4D, which is 12D. Divide both sides by 12, and we get D equals to 3. Okay, now that we know our difference, D is 3, we can either go backwards from 24 to figure out the first 4 terms, or if I want to go forward, I can find my first term. So let's actually do that so that we can practice using our substitution and elimination. So we're going to take D equals 3 and plug it into one of our equations. So I'm going to go 24 equals T1 plus 4 times 3. So 24 equals T1 plus 12. So T1 equals 12. So by doing this, I actually will find the first term, and now I can add the difference of 3 until I get 4 terms. So my sequence is then 12 plus 3 is 15, plus 3 is 18, and then plus 3, I get 21. And to double check, if I add 3 again, I do get 24. Now this way may be a little bit longer because I don't have to actually find T1. I can actually go backwards from T5. But if I was given maybe not T5, but a larger term, then this might be the more convenient way. Let's take a look at another example that is an application. All right, so in this one here, many factors affect the growth of a child. Medical and health officials encourage parents to keep track of their child's growth. The general guideline for the growth in height of a child between the ages of 3 years and 10 years is an average of increase of 5 centimeters per year. So this is from 3 to 10, and the increase 5 centimeters every year. Suppose a child was 70 centimeters tall at age 3. Write a general term that you could use to estimate what the child's height will be at any age between 3 and 10. All right, so let's list our information. So T1, N, D, and Tn. Okay, so because we're looking for the general term, N will still be N and Tn will be Tn. Now for T1, we can use that to be 70 centimeters, our first term. And the difference is an increase of 5. So I'm going to say that it's 5. So I'm going to rewrite the formula and show you how we're going to use it. So we're going to go Tn equals T1, which is 70, and then plus n minus 1 times 5. Now there is a little bit of a problem. So let's say that I want n to be the age of the child. So when the child is actually 3, and let's say I plug this in, okay, so T3 is 70 plus 3 minus 1 times 5. So I get 3 minus 1, so it's 2. 2 times 5 is 10. So it sounds like it's 70 plus 10, which would mean that when the child is 3, they would be 80. So that's not correct. So what I want to do is I want to make a general term or a formula so that the n actually stands for the age, okay, and actually not the term number. Okay, so I'm going to erase all of this. So what I want to do is I need to change the formula a little bit. So when the child is 3, they're going to be 70. So right now what's happening is when I plug in the 3, I still have a value here, but I actually want that value to be 0 so that when the child is 3, I only have this constant term there of 70. Okay, so what I'm going to do is instead of subtracting 1, because I want that bracket to be 0 when the child is 3, I need to actually subtract 3. Okay, so if I plug in 3, if I do a check now, T3 is equal to 70 plus 3 minus 3 times 5. This actually now gives me 0. So when the child is 3 years old, indeed they are now 70 centimeters tall. Okay, so just to simplify my formula here, I'm going to say Tn equals 70 plus 5n minus 15. And then Tn equals 70. Oh, sorry, not 70. 70 minus 15 is 55 plus 5n. So this is my general term, okay? And I'm going to add a little thing where n is the age from 3 to 10 years. Okay, so this formula doesn't apply when they're 1 and 2 because there's a different formula there. Part B says how tall is the child expected to be at age 10. So now we can actually use our formula because n is the age. So T10 equals 55 plus 5 times 10. So T10 is 55 plus 50. And when the child is 10, they are 105 centimeters tall. So read the questions very carefully, and you might want to set it up depending on what you want the n to represent. And in this case, we actually want it to represent the age and not actually the term or the position of the sequence.